the problem blockchains have in terms of scalability, and then you talked about Starknet as a layer 2 scaling solution for Ethereum. Then you went on to talk about Starknet family, then also teaching us about validity proof and validity rollup and how they both work. So then we now stopped at smart wallets and the explanation about it.
Okay. That's fine. That was really good. Yeah. So did anybody go back to go and check out resources that that was being dropped? So did I have much to check? I think yeah, that's fine basically. So okay, hi. In case anybody's new again, it's my name is David Sule, and your tutor. This is the second session for week 1, and if you have any questions because of time, you can just drop it in the call messages, and then I will answer you immediately when I see the message. I see the message. So yes, let's get to it. Okay. So let's do a little recap. So why Starknet, Starkware, StarkX, Starknet? I think you already explained that. Okay, so can someone tell me what they remember is validity proof again? Anybody? Okay, so anybody remember what validity proofs are? Anybody's going to try? Yeah, Mr. Akapo, you can speak. Mr. Akapo can turn off your mic and speak. Or is that a mistake? Okay. Yeah, I want to assume that was a mistake. So I'll just continue. We don't have much time. So today let's talk about understanding Starknet architecture. So now think of Starknet as a powerful assistant that helps Ethereum scale. I think we should understand that by now. So now instead of running every transaction on Ethereum, Starknet bundles thousands of transactions and proves they are valid and sends just a small proof back to Ethereum. So I want to walk you through components slowly. So yeah, this is the basic timeline you guys can see. So it goes from the your wallet or your PC, then being compiled in Sierra. We'll get into that in a bit. Then it is sent into Starknet sequencer and it is compiled in Casim, and then it is run in the Cairo virtual machine, and then it's also traced in a prover. Then it is verified in Ethereum, which is validity proof again, and that's the basic whole timeline. So, does anyone? Okay, I have two people raising their hands. You can turn off your mic and ask Mr. Douglas. Yeah, Mr. Douglas, you're raising your hand. You can ask your question, sir. Or was that a mistake? No, I can't hear you very well.
You asked about validity.
Can you speak louder? I can't hear you. Oh, you can drop your question in the call messages so I can see it.
more insight on the validity of sorry from the
I really can't hear you. Just drop your question in the messages while I just explain. Okay, then I'll get back to that sooner. So now in this whole, this is the Starknet modules basically. So now every wallet on Starknet is actually like a smart contract. We'll get into that. So now it signs transactions, defines how to pay fees, and communicates directly with the network. So now I want to explain what a sequencer is. So now a sequencer is like Starknet's, to me, like traffic controller. Like it receives transactions from wallets and then check signatures and balances, orders them and executes them inside the Cairo virtual machine. VM stands for virtual machine. So now the virtual machine is where your Cairo code actually runs. Like this whole session, it's going to be tricky to, not tricky per se, but it's a more developed. So just bear with me and let's understand this together. So now a Cairo VM is where your actual Cairo code is going to run, and then the prover in this case, which is sharp, the prover here is sharp. The prover then compresses the entire execution trace into a short mathematical statement. Yeah, that's fine, Mr. David. So the prover compiles execution state into a short mathematical statement, which is validity proof. That says that everything in this batch was executed correctly, and then is valid. So that's the basic analogy. So did this make sense? Make reactions. Okay, Mr. Kafo. Okay. So now let me explain. So the way Starknet works, is that it is, you run the program, the Cairo program on your PC, like a laptop. So it is being compiled in Sierra. We'll get into that later. So now it is now sent to a sequencer, Starknet sequencer basically. Then it is being compiled in Casim. We'll still get into that later on. And then it is run in Cairo VM. So if you're familiar with like cloud, like native cloud terms, VM means virtual machine, which they are what runs the code and outputs functions and all that. Then it is being traced with a prover. In this case, the prover is sharp, and then it is sent to Ethereum, which is the verifier, to validate the proof, and then it outputs a result basically. So let me check if there's any questions. Okay, so I think that's all for that. Then I can ask a few questions. So this is basically everything. It's not that complicated. Mr. Kopfor, you have a question?
Okay, please, I just want you to like reiterate what you mean by sequencer.
Okay, now so the sequencer basically it runs code while prover proves code. It's not anything too complicated. So now let me go back. Now these are like boxes. This is you. This gray box is you. This other gray box is Starknet, like how Starknet is running everything. Yeah, then this is the prover, which is sharp. This is another entity on its own. And then this is the verifier, which is Ethereum. So now in Starknet, Starknet is going to run your code in a sequencer. So the activities being that is happening in that sequencer is that your code is compiled in Sierra. It's is being sent to Sierra, it's being compiled in Casim, then it runs on a Cairo VM, and that's sent to the prover, which is Sharp, and then that's output a validity proof and the rest of the timeline. Does that make sense? Does that make sense? Okay, yeah. So if you have any questions, anybody, so we beat today. Mr. Izuchukwu raised his hand. That's fine. Okay, no questions. Okay, that's what it is. Back
Just a
to what I
question.
was saying. Yeah. Go ahead.
Can
Yeah,
we say the sequential is like the batching system in the stack process?
Can you repeat that? Like, what do you mean?
Like the batching of stacks.
Okay. The sequencer receives transactions from wallets. It checks signatures and balances, orders them, executes them in the carrier machine. So it's like basically it does it does most of the workload. Like, you have a carrier program on your personal computer running, so it is being sent to Starknet. It's being sent to Starknet, and then Starknet sequencer is going to compile that in Casim, run that in Cairo VM, and then is going to trace that to Sharp. So that makes sense.
All right.
Okay.
All right.
Yeah, let's go quickly. Yeah, so that's basically it. So now, why is it oversimplified that Starknet uses smart contracts? Starknet uses smart contracts. So before executing a smart contract, it must be declared and it must be deployed. So the user interacts with Starknet via transactions, and then transactions must be signed. So I want us to understand what like declaring contract and deploying contract are. So declaring contracts, declaring registers your contract class on Starknet. Then you send the compiled bytecode and get back a class hash which uniquely identifies the contract's logic. So now deploying creates a live instance of that class with its own storage and address on the network. You get my point? Is anybody confused about what those two terms mean? Yeah, that's cool. Now, the analogy is that declaring is uploading like the design basically, while deploying is manufacturing of that manufacturing based on that design. So now, key terms that you need to understand is class hash. Class hash is like the fingerprint of the code, and then address is the unique location of that instance. Then constructor runs once at deployment. So I would have showed like a tiny demonstration of Voyager, but still trying to beat time. So let's accelerate a bit. So this is the basic timeline. So we have you compile the Sierra, it creates a transaction in your wallet. It declares that in mempool and then compiles that to Casim, and then it's sent to approver again, and that's basically it. So moving forward, so now proving compilation, the Cairo compiler is written in Rust, so compilation can't be proven because Cairo is built on Rust, but in the long term, it should or will be written with Cairo. So now the long-term solution is to the Cairo compiler in Cairo, and then compilations are proven. Now the storage gap solution is that we should later provide a caching hash while declaring, and let sequencer recompile Sierra to caching and compare hashes. This is low lots of, yeah. So this is the basic analogy. So from you being compiled in Sierra, compiled in caching again, and then creates transaction on your wallet, then it declares that transaction. It's containing a Sierra code and caching hash, and then it is sent to Starknet, sent to mempool, and then it's compiled again in caching, and that's the whole basic timeline. So now this is client versus deploy. So now, yeah, let me shut up everything up. Now, declaring a smart contract registers its code on Starknet, while a declared smart contract is known as a contract class. Now, a contract class is ID'd by its class hash. These are all different terms, but we'll get to understand upcoming in probably week 2 and further months. Now, contract classes are pure code. They have no storage, basically. Now, contract instances can be derived from contract classes, like in object-oriented programming, if you are familiar with that. So now, this is like a visual illustration where you have a contract class which contains a contract instance, class hash, and yeah, let's continue. And the contract instance has storage. Contract instance is ID'd by its address. So now universal deployer. So now smart contracts that deploy other smart contracts, basically. Now only one selector deploy contract. Selectors must be invoked with blueprints, class hash, and constructor arguments. Then internally they used deploy syscalls and deploy. Okay, is anybody following? Okay, Miss.
I'm lost. I'm lost. Seriously, I'm lost.
Okay, let me drop the links to the slides so that you can be following me consistently, so it's not be that difficult. Okay, Mr. Anthony, you raised your hand.
Yes, yes. Good evening, everybody. Can
You
you
can
hear
ask
me,
a
please?
question.
Please, can you hear me?
Yes, we can hear you. We can hear you.
Okay, please. I think initially from the beginning of this class, I was thinking that one of the, should I say the prerequisite is having knowledge of normal Web 2 designs. But then, sorry, I'm still on the road, so I don't know, it can get some noises sometimes. But then, with the terms I'm hearing, I don't know if this is happening to any other person. I would have preferred if there is maybe a breakdown of maybe a kind of pre-knowledge to what you are saying, because I think that's why almost everybody's lost. You understand? I'm understanding some terms, but then I'm not
I'm sorry,
understanding
I
most terms.
don't understand what you mean. Can you repeat that?
Can you hear me now?
Yeah, I can hear you
I
now.
believe I can rephrase what he's saying.
I was saying, is there can we get a list of maybe, let's just say we can dedicate tomorrow to learn more about this is so prerequisite knowledge before now? Because I was thinking that just maybe having some key knowledge of the Web 2 technology, be it the CSS, HTML, then JavaScript and whatever, we give you access,
No,
being
no.
balanced for this knowledge. But then I'm seeing that almost everybody is lost because most of the times here is not normal thing for the Web 2 technology or stuff like that. So I don't know
Yeah,
if
but
there's a way we can bridge this.
except if you have like knowledge, because when I started bootcamp, last track, I thought it was going to be easy to migrate from Web 2 to Web 3. But basically now you're doing more of logic learning. So it's not like front end where you can visually see what you're working on. And so it's more or less for you to understand the logic first, and then around week 4, or is it week 5, you start developing like actual decentralized applications and probably DeFi applications. So I hopefully like later I want to compile like a list of terms that one should know. So but let's just keep on going. Let's just see where we can reach so that time does not, so that we can beat time today on like the last class. But so far, is anybody having any issues? Okay, I'm Mr. Richardson.
It's okay.
Yeah,
It's okay. Thank you very much. Sir.
Hello everyone. Today I'm sorry I quite resumed them late. But the last time when I was here, or the last track, when I mean last, I mean the previous Wednesday. We ended. I really understood everything you said there. I was the one who was buttressing on that receipt analogy you gave. So and today actually I resumed by 8:44, and immediately I just entered. The first thing I was just hearing is carry this and contract. So I'm not going to ask you to start from the beginning, because most people are following you. But I want you to just like have it in mind that maybe if you can be like buttressing on some point, so that at least people that are following can follow. But I understand all this. I understand programming because I'm a developer, but I want to just like understand what, like, the idea of what you are saying, so I can just follow on and be going like that.
Okay. Yeah, that's fine. Basically, I just want to see if I can hit with time first. Then once I can do that, I am willing to stay at the end of the class. Anybody that's still having maybe
All right.
like issues, whatnot like that.
It's all right. It's all right. You can continue, sir. Yeah, thank you.
Yeah, okay. Thank you. So let me just, okay, no. Before I continue, let me just talk a little bit. So I think most of you are wondering what Sierra Kasim probably is. So now let's talk about your Cairo code, how it becomes something that Starknet can actually run. So now Cairo compilation pipeline is more or less like this. So you write Cairo, so you write Cairo code basically. Now the compiler converts it into Sierra, which is an intermediate representation. So now Sierra is now being compiled in Kasim. Kasim is, I think, this is short for Cairo assembly, and then it is now being sent to the virtual machine. I think that was illustrated. So now Kasim is what actually executes on the VM. So now the issue is that the compiler is written in Rust. Most of you are probably familiar with Rust. So now Rust isn't yet provable. So now the compiler is written in Rust, which is not yet provable. So how does Starknet ensure that the compiler didn't alter the code? So now when you declare a contract, you submit both the Sierra code and then the expected caching hash. Caching hash is a unique identifier. So now the sequencer recompiles Sierra, and then it is being compiled again in caching, and then that checks the hash and checks the matches and if your declaration is valid basically. Did that make sense?
Yeah.
Mr. Franklin is raising. Yes, sir, you're raising your hand.
Can you
the explanation was really good though. But I don't know, maybe because I joined late. But some of these things I'm not really understanding.
Okay. So what exactly don't you understand? Let's see if I could help.
Let me start with that part of the calcium hash I'm talking about.
Okay, calcium hash.
Yeah.
Listen, let me explain. Let me try to again. Can turn off your mic still because I think it's repetition. Mr. Samuel also have a question, but let me explain first. When you write Cairo code, when you write code in Cairo, so now the compiler converts it into Sierra, and then Sierra is being assembled in Caching, which is Cairo assembly. That's I think what that stands for. Then Caching is now being run. The actual code of everything is now being run in Cairo's virtual machine. Okay, I think that should make sense. Mr. Samuel, you can ask your question, sir.
Okay,
Mr. Samuel, can I?
is concerning this the slide link. It's not public. I can't use it. It's not public.
Oh, okay. I think it's private right now. It's private right now. So you can turn off your mic so it doesn't reverb. Oh, I'll make it publicly outside class because we are really not meeting up to time. Sorry. Okay, so yeah, so I was talking about universal deployer. I think that was already. Do anyone have any question, like anything they don't understand when it comes to universal deployers? Okay, so I think we can move on then. So now, smart contract classes versus instances. So this, let me set up the whole. So now, this is Starknet. Let's go back. So now, Starknet declares a transaction which is a smart contract class. Okay, now it invokes that transaction through a universal deployer, and then due with constructor arguments and all that, it creates a smart contract instance. Yes. So now that's the whole basic, because you need to understand how declaration works and invoking works. But just bear with me for a while because these are somewhat complicated terms, but we are still going to understand. So I want us to finish up with the entire slides, then we can start working on with questions and all that. So now, deploying a smart contract. So it's your laptop where your wallet is. So you invoke a transaction which contains a class hash, constructor arguments, and UD address, and then that it's compiled in the mempool, and then it executes in Cairo's VM, and it is now being traced again, as I've said before, in Sharp, and then it is sent to Ethereum to be verified and validated. So that's basically it. Now invoking, sorry. Yeah, so invoking a smart contract is basically the same timeline, I would say. So now let's just summarize the whole architecture and everything. So now Cairo compiles to Sierra. Sierra compiles to caching, like we've explained. Now, declaring creates a contract class, and then contract classes are now derived from contract instances are derived from contract class. So a contract class can be used as a library, and caching hashes are used to prove compilation, and then deploying requires a universal deployer, and then transaction types. There are two transaction types, which are declaration and invocation, like declare and invoke. Mr. Joseph has a question. You can drop your question in the call message so we don't waste time.
No, I said I'm writing those things down. I was writing the
Okay,
deploying
okay. That's good. That's good.
Or
That's good.
this thing be provided later because I like writing while you're talking. But unless I
Okay,
provide it, let
I'll
me.
provide it. Yeah, very later. So before I continue, let me just try and explain the whole transaction life cycle. So now your wallet creates a transaction. It specifies the target contract or like the function selector basically. So now the sequencer receives it and checks if the signature is valid, if there's enough balance for gas, like if you want to send like probably $10 worth of stock and then let's say it's $9 you have in the account, it won't work, it won't execute because you have less than what you're trying to send. Is the nonce correct? Is the structure well formed? And then after all that is being clarified, the stage 3, which is the execution, if everything checks out, everything is okay, the sequencer executes the call inside the Cairo VM and then records a trace. Then after that is now the proof generation, which the prover bundles many traces together and then generates a single validity proof that is being submitted to Ethereum for final verification. So now I want to explain like the statuses, which is in the case of a transaction being accepted on L2 and L1. So now being accepted on L2 means that it is executed and confirmed on Starknet. Then being accepted on L1 means it is proof verified on Ethereum. So now I think that basically should make sense. Does that make sense? Okay, so let me see if I can do something real quick. So give me a second. I'm going to demonstrate something real quick. So before I go further, has anyone created their smart wallets, the smart wallets accounts like Bravos and Urgent's accounts? I use Bravos personally, but you can use whatever you want to. Anybody have any issues creating the Bravos accounts?
No,
Okay,
actually,
nobody
this
has
is the first time
created.
I'm hearing that. Yeah, this is the first time I'm hearing this thing. I've not created. I've not even heard of it. Please.
Okay, so these
Bravos,
are
Bravos
small.
wallet. I've created Bravos.
Okay, I created a Bravos account. So
Yes.
have you deployed your accounts basically? Like to deploy an account, you need to fund and create a transaction in with the account. So
No, I've not done any transaction. I just created the secret. I was hoping to fund it earlier, but I got carried
okay,
away with some stuff.
let's fine then. I think we'll leave that to the end of the class then. So now let's understand how transactions work. So now transactions types. We want to talk about transactions basically and counterfactual deployments. So now Starknet supports 3 main types of transactions. So we have declare, we have deploy account, and then we have invoke. Those are the 3 basic types of transactions. You get my point? So what I want to talk so
Please, what did you say that the fraud transaction is?
has a new contract class. Okay, then we have a deploy transaction. So that one creates a new smart wallet, which is what I was talking about. So when you deploy your when you create a smart wallet, that's the type of transaction that happens. And then we have an invoke transaction which executes contract logic. we'll get into much more detail on understanding these terms probably next week and the upcoming classes. So just bear with me and just so you make a transaction on your phone, it is being compiled in mempool, and then it is validated with the transaction signature. Then it checks if you have enough gas fees, enough gas like charges, whether you have enough charges to execute that transaction. Then it's compiled in Cairo VM. So it's not traced again to a prover, which in our case is Sharp, and then it is validated with in Ethereum. That's
So I don't know if you are talking, but I can't hear you. I don't know if you are responding. I believe my network.
Same here. I'm not hearing him.
I think he's having network issues. So let's just hold on
The network
until
has
he
really been
online.
bad. Maybe he's expressing network issues too. Because me too here, I'm just managing to be here.
Nigeria for you now. For those of us where they you talk.
I swear, that kind of thing.
God, I beg.
My God, go help us.
Bro, network did there. This one did there. How you go understand this one first? Your mind go deep.
But my network for here, they clean.
Aji, take a play first now. Oh, oh no.
so did I go off? Because what remind me why I stopped, because I was just talking and
But
I didn't
so
get any
remember when
response.
you stop, go hard. Oh. I don't know if anybody's following. Please.
I didn't follow.
No, I think you are just trying to explain the transaction, you know what you call it, the transaction life cycle or something like that, please. You are trying to
Um,
explain how from the mobile wallet to something like that.
okay. Oh god, this is a difficult class. So I think I began to explain the transaction types. So I think we just continue from there. The the other is not really that important for this class yet, but consecutively we'll tend to understand what they mean and why they are relevant. So I think I was my network cut of I think we talk about the types of transactions that we have. So the first one I already told that there are three. So we have a declare. My voice is breaking. So my voice is actually breaking. Okay, so we have a declare transaction. Instead of have declare, we have invoke, we have deploy accounts basically. So declare, which registers a new code on Starknet, plays this. So that's here. So invoke executes write functions in the sense that it executes contract logic. You don't need to understand basically what that means now, but you will soon. And then deploy account is the kind of transaction that happens when you deploy a contract, an account contract, which is a smart wallet, basically. So let's go in. Now, I want to talk about counterfactual deployment. So before we continue, can someone list and explain the three types of transaction types and what they do, like what's their function? Then sort of your mic can just speak actually.
Okay, first transaction type, we have declare, registers new code on Starknet, then invoke, executes write functions, then deploy accounts, the type of transactions for deploying an account contract or a smart wallet.
Okay, that's great. Great. So I want to talk about what counterfactual deployment is now. So now Starknet can compute your seats ahead of time. Address same input relative to the same addresses basically. So like the analogy is like it's like reversing a house address before the house is actually built, because uh did that make sense? It's a situation where you can reference transactions ahead of time before they actually being deployed. So let's read through what we have on the slide. So you deploy an account contract, and then after deployment you pay for gas fees, and then your smart wallet is being deployed. Let me check if there are any questions first of all. Okay, so let's continue. So now, how do you deploy an account contract if you don't have an account contract to pay gas fees? So you calculate the address of chain, you send your funds to the would-be address, which is the person you are sending you are making transaction with. Like I'm making a transaction to you, I'm sending $10 worth of stack to you, and then you deploy the account contract using the deploy transaction, and then sequencer deducts gas fees from the address. So that's basically it. So now let's just summarize what we have for the transactions. So transactions, we have declare, invoke, deploy. And then the transaction lifecycle is you receive a transaction, it's then accepted on L2, then accepted on L1, then it's either rejected or reverted. It says that if there's either one or two misvalidations or whatsoever, it is can be rejected or reverted on L1. So but before moving forward, okay, I know my screen. I want to ask a question. Can someone explain what accepted on L2 and L1 means? Okay, Mr. Innocence. Like, so you can just unmute your mic and speak. Like, what's accepted on L2 and L1 means?
Okay, good evening. Um, from what I understand, accepted on L2, when the transaction is placed, like it is
Yep.
received and Starknet, the L2, is going to compile it or bundle it. Then when it bundles it, it's going to let me see, send it to the L1, that is Ethereum, the main blockchain. So Ethereum now is going to prove it, like have a validity proof for it, and then it's going to do it finality or stuff. That's what I understand.
Yeah. I think I'm saying like that was good actually, but I want you to get the terms right. When you say that and a transaction is accepted on L2, what does it mean? And the transaction is accepted on L1, what does it mean?
I say from what I understand, when it's accepted on L2, that is the layer 2 network, like Starknet itself, is going to be bundled, or then it's going to be bundled now, or rolled up, like it's going to roll up, then it's going to be I don't know if it proof, if there's going to be any validity proof or stuff before it's sent to the L1, the L1 is going to do the validity proof then before there will be any finality. for a transaction.
Okay, that's very good. But yeah, that's very good. So in the simplest term, okay, Mr. Okafor is raising his hand. The simplest way to explain it, transactions being accepted on L2, which is Starknet, it means that it has been validated on Starknet, and it happens instantaneously, like very fast. And then transactions being accepted on L1, it's going to take longer because of the whole validity proof timeline and all that. So yeah, that was very good. Mr. Okafor is raising his hand.
Okay, no, you just like answered the question because I wanted to before how you talked about L2 and as being accepted on L2 and being accepted on L1. You are like being accepted on L1 is when it is proof verified. So I do not understand being accepted on L2, but you've already explained it again. Thank you.
Okay. That's amazing. Let's just move on. So transaction finality, I think we already understood this from the last class. Okay, how long does it take for finality to occur on Starknet? Can someone tell me?
10 seconds.
Okay. That's no, like from the last class we had, like what was specifically there? Okay, let me put it out. Do you remember this? Do we remember this?
Call me ma.
Do you remember this? Anybody? Like, I need react. Okay, Mr. Okafor has a question. You can turn off your mic, sir. Oh, was that a mistake? I think I'll just assume that's a mistake. So, yeah.
I don't know if
Innocent,
I don't
your
know
voice is breaking. If you can.
if it was 45 hours. I don't know if it was 45 hours on Starknet.
Okay, yeah, this is L. Okay, Mr. Okafor, you can raise your hand. You're raising your hand, so you can ask your question.
Because I don't understand this 10 seconds that is now here. Is it like finality on just the L2?
Where is this in 10 seconds?
See L2 finality.
Yeah. What? L2 final. Okay, yeah. This is L1 finality. This is how long it takes transactions to be finalized on L1. So like
Okay.
imagine this is layer 1, this is layer 2, this is layer 1. So now let's just use like physics or whatever. So a transaction, it's the whole timeline is happening this way. So for finality to occur on L2 means on this layer, it's going to be faster than if it was going to occur on the lower layer, which is layer 1. So finality on L2 is way faster. Like for transactions to be finalized on L2 instantaneously, 2 seconds, 10 seconds, it happens very fast. But now this is L1 finality. So after being finalized on Starknet, it still has to be validated and finalized on L1, which is Ethereum. Does that make sense?
Thank you. Yes, it does.
Okay, Mr. Okafor.
I said yes, it's me. Yes.
Okay. Just consider. So this is what I mean. L2 finality takes less than 10 seconds. 2 seconds most of the time. Happens instantaneously. So this is what we'll talk about on the mempool. So now there's no fee market on Starknet yet, but transactions that are executed in the odd someone raised their hand. Mr. Levi has a question.
Yes. Can you hear me?
Yes, I can.
About the L1 finality, You said that transactions on L2 take 10 seconds. Or was that what you said?
It takes less than 10 seconds.
Less than 10 seconds. Then what's the 5 hours that is written there is for what?
That is for L1 finality. Let me go back. That's for L1 finality. Do you understand?
But is Starknet an L1?
No, Starknet is an L2, it's a layer 2 scaling solution to Ethereum. So it's like how do I put it? Okay, let's say let me use the whole house sales boy analogy I tried using yesterday. So Ethereum, I have a house where I am doing a load of paperwork. Let's say probably like in Victoria Island, like that, basically, or mainland like that. So it's a lot of work. So I have to give my sales boy, which is off chain, which is off my house. It does not my house. It's not my house. So my house, let's call it layer 1. It's the headquarters, so it's layer 1. Like him, like I'm giving him some part of the work. That's layer 2. So for the transactions or the files or the paperwork I give to him, for him to finalize it on his own level, which is layer 2, it's going to take less than 10 seconds because it's going to be very easy. He's there with the paper, so to finalize it will not be too difficult. So now for him to now finalize it on L1, which is my house, you have to take a cab, go to school, lectures, whatever, come to my place. That's going to take a lot of time. That is now about like 5 hours. You get my point? You get my point?
Yes.
Does that make sense?
Yeah.
Guys asking a question.
Let me get it right. These finalities we are seeing on the projection Ethereum, Starknet, and optimistic rollups. Now, in the bracket, we are also seeing numbers representing each of these programs. Are we to say that these various numbers represent their finality each?
Can you explain what you mean? Like, I don't understand what you're trying to say.
Okay. What I was saying is that, judging from the projection, we are seeing Ethereum, Starknet, and optimistic rollups, and then there are numbers on each of these programs. Now, am I right in saying that these numbers represent the finality for each of them?
Those numbers that you're seeing, it represents how long it takes for transactions to be finalized on L1, layer 1. So you could say that yes, that's more or less correct.
But I was thinking layer 1 is supposed to be Ethereum, then layer 2 Starknet.
Yes, layer 1 is Ethereum, layer 2 is Starknet.
So how do you connect
Like,
all these numbers now? How do you connect them?
Okay, I want you to ignore this. Ignore this red, what you're seeing here in red. Ignore that.
Okay.
So ignore that. So this is okay. Let's say this is Ethereum. This is layer 1. This is the first layer. Then you have a layer built on top of it, which is Starknet, basically.
All right.
So now transactions that are bundled off chain, because you're working with Starknet. So transactions that are bundled off chain, because Starknet is built on Ethereum. Ethereum is the main blockchain, so it still has to send and validate the transactions on the blockchain, which is layer 1, which is Ethereum. Okay. So now, finality, we have, I could say there are two types of finality. So we have finality on layer 2, and we have finality on layer 1. So how long will it take for a transaction to be finalized on layer 2? It takes less than 10 seconds, which is the thing you see in red over here. Because it's like, let me use the federal government setting. So now you're working, or they're doing probably, okay, you're working. It's like a federal institution. So now it will take you quicker, because let's say you are layer 2 and then the headquarters is layer 1, like that. So you have a bunch of paperwork and everything to file and everything like that. So it's going to take you much. It's going to be easier for you. It's going to be faster for you to finalize um particular paperwork at your own level, which is level 2. On your own level, you're going to take way more faster. So now your level is what, level 2. So which is Starknet. So it's going to take a whole lot much faster time, like less than 10 seconds, to finalize it on level 2, which is your level. So now for that finality to now occur on level 1, it's going to take much more time, because or let's say the headquarters is in probably like Abuja. You have to take a flight to Abuja, everything like that, get a cab to your hotel, sleep. That could take a whole lot of time. So now, how long it takes you to finalize on layer 1, like moving, how long it takes you to finalize a transaction from Starknet to layer 1 Ethereum is going to take way much time, which is like 5 hours. But now, for a transaction that is already bundled on layer 1, like a transaction that was already calibrated and validated on in the headquarters, like the person is already in Abuja, the worker is in Abuja, he doesn't have anywhere he's going. He's not in any, he's not with any time deadline or whatever. So he's already in Abuja, which is the headquarters, which is layer 1. So on layer 1 level, it's not going to take him long at all. So he's not going to walk upstairs, maybe a few stories, and go and finalize that particular paperwork and or application or whatever. So that takes him about like 6 minutes. But for you, for transactions that are happening on Starknet, it's going to take much more time, man, like that. Hope that made
All right.
sense. 'Cause
Very,
that's
very,
the
very, very
gist.
well explained. Thank you, sir.
Can everyone hear me? Okay. So Mr.
Yeah,
Innocent, you can turn off your mic and ask a question. I think Mr. Innocent and Mr. Uwa.
Okay, it's not really a question. Like I want to see my own understanding to see if it's correlated to what you have been saying. So for this finality and the time, let me use this example now. Let me say for Starknet being the layer 2. For the finality on this layer 2 now, when it confirms the transaction and then it validates it, that is the time finality. As you say, this instantaneous, takes 2 seconds, 10 seconds.
So can you repeat what you're saying?
When it confirms the transaction now and validates it, that is finality. So that can you hear me? Can you hear me?
I'm finding it difficult to
Can you hear me?
saying, but continue. I can hear you now.
Okay, I was saying I was trying to see more understanding of this actually on finality. I don't know if you can, please can you hear me? I don't know if you can hear me.
I can hear you. I can hear you.
Okay. So I was saying that this layer 2 finality, the time frame like on Starknet, that is the L2, for it to confirm and validate the transaction, that process now is instantaneous, as you say, 2 seconds, 5 seconds, 10 seconds. So for the time it will take now, when it's done confirming, it is going to bundle these transactions off chain. So when it bundles them, the process of bundling it, sending it, let me say bundling it, proving it, and then sending it to Ethereum blockchain. That
Yeah.
L1. So before, let me say, before it gets to the L1, all those the time it will take for it to get to the L1 is the 5 hours
Yes,
it will
that's
take,
technology.
and then that 6 minutes is the time that Ethereum is going to do the finality on the proof it has received. I don't know
Yeah,
if it does right.
that's really cool. That's really good.
Okay, that's it. Thank you.
That's amazing. So okay, so I want to explain what mempool is. So transactions are executed in the order they arrive. You can't pay more to jump the queue. And okay, this can you guys see my screen? Yeah. So basically, you can read through what it says there in the slides, but this is the best I'm going to explain what a mempool is. All of this is just to me the easiest way I can explain what it is a mempool is someone like a waiting room for transactions, in the sense that, like it says, transactions are executed in the order they arrive. So if this transaction happens first, maybe it's $5, next one $10, it happens in the order in which they arrive. So a mempool is something like a waiting room. So now you cannot pay more. You can't say that you're going to give more gas fees or whatever. Yes, I will. I mean, will, Mr. Kelechi. So you can't say that you want to pay more to maybe cut the line or whatever. So a mempool is just like an area where transactions pile up, not pile up per se, but they are executed in the order they arrive, like transaction 1, transaction 2, transaction 3, transaction 4, let's say like that. So before transaction 2 can be executed, transaction 1 has to be executed first. Transaction 2 has to be executed first before transaction 3 can be executed, and subsequently like that. So yes, I will, Mr. Uber. Did that make sense? Did what I said about mempool make sense? So right now, Starknet uses a simple mempool, like first in, first out. There's no bidding in Ethereum gas auction. So that's basically the whole analogy. So let's keep on going. Okay, transactions gets executed on L2. Finality is less than 2 seconds. So transaction gets added to a pending block, and then a new transaction arrives to the sequencer, and then a new transaction. This is another transaction. This transaction 1, this transaction 2, and then the transaction arrives to the sequencer. The same process repeats. So transaction 1 must be executed. You can see they're all pending. So transaction 1 was executed first before transaction 2, and then subsequently like that. So I think the max size for a transaction is 10 million Cairo steps, and yeah, I think I should be sure. Yes, 10 million Cairo steps. I think that's enough for that. So now events timeline. Sequencer receives the transaction. So now transaction executes L2 finality. This, like, listen. Sequencer receives the transaction, then the transaction executes L2 finality. Then a block is created, like a transaction block is created. Sorry. Transaction block is created, and then takes time and everything, the whole timeline and everything, and then it takes about like 10 hours to now validate it and verify it on L1, which is now L1 finality. So you see that, like the way I explained earlier, this gives more clarity to the whole L2 finality, L1 finality confusion. Does that make sense? Anyone having any issue? Okay, Mr. Uwa can ask a question. Mr. Innocent, your hand is also up. So let Mr. Uwa ask a question, and then Mr. Innocent can ask a question.
Maybe it's a mistake. I don't have a question. I don't have a question.
Okay, you're raising your hand, so you can just that was a mistake. Mr. Innocent, you can ask your question, sir. You're free to ask a question, sir. Okay. I want to assume that was a mistake, so I think we just proceed. So this is the whole summary of what transactions are. Transactions are executed in the order they arrive, and new
Sorry,
transactions
I
are being added
have a
to.
question. I forgot the amount of means.
You have a question?
I forgot the amount of
Yeah, you're breaking out. I can't really hear what you're saying.
series
But
of.
if you have a question, you can just drop it in the in-call messages and respond to that. Okay,
I
so
don't
let's continue. So
have a question.
this is the summary of transaction finality. Transactions are executed in the order in which they arrive. New transactions. When a new transaction arrives, it is added to the pending block. Then transactions are on L2 level, on layer 2 level, are executed right away, which is less than 2 seconds. That's what it happens very fast. And then once L2 finality happens before the block is finalized, and then a new block is created, and then a block can hold 45 million Cairo steps. Then a transaction can hold up to 10 million Cairo steps, and that's the whole summary. So next, I'm going to be talking about what full nodes are. So I think we have a few developers in this call. So does anyone have any idea what nodes are?
Yeah, I think for me, my own understanding of nodes are computers that are participating in a blockchain. Did you get that?
Okay. Yeah, I get that. Does anybody
Okay.
else have like a different opinion? That was good actually, but anyone have like anybody has anything else to say?
Yeah, in electronics, for instance, a node can be more like the point. A point. Let me use just the simple word, a point. Sorry. So maybe I don't know.
Okay,
More like meeting point. More
that's
like meeting
nice.
point. Yeah, more like meeting points.
Okay, I didn't know that, but
Let me
that's
say
that's let me read
maybe
it.
a mini
Okay, a
processor.
node.
Let me say a sub processor, something like that. A sub processor.
Yeah, yeah. Okay, yeah, that's so nodes are like I think
Okay.
the best word to explain nodes are like processors that process large loads of data and all that. So full nodes store entire states and serve data to wallets and explorers, but they do not sequence transactions. Uh let's see. Let's read what's later. So a full node answers questions about the Starknet states. Users don't directly interact with the sequencer, only full nodes do. So equivalent to an execution client on Ethereum. So Starknet has different full nodes. You don't really need to know deep details about what they are right now, but just know one is Juno, the other one is Pathfinder, the other one is Papyrus, and then the fourth one is Madara. So yeah, so this is a quick recap on full nodes. A full node answers questions about Starknet. Let's just use this as a definition in case it is asked in the assignment. So this would be a very good answer. Now the four implementations is Juno, Pyrus, Madra, and Pathfinder. And then the state manager is part of the sequencer. So Starknet stores block roots on Ethereum. They can be used for block verification, and Starknet core is also used for L1 to L2 messages. Give me a minute to make the slides public. But before I continue, let me just do something else. Yeah. Wait a second. So, okay. Okay, so I wanted to do a slight demonstration. I don't know if you guys can see what I'm saying. So this is what I was saying. I think this is my old Bravos account. Let's just quick demonstration. Yeah. People have money inside here. That's nice. So this is my Bravos account. I think I made this a long time ago. So I currently have like 4 stacks inside here. Price of stacks are really gone down. It's bad, but it's still okay. I have 4 worth of stacks now inside here. So I wanted to deploy someone's accounts. We can, okay, let me use an example. Let me see if I copy my address now and paste this in Starknet. Should output um yeah, Starkscan is more like a global explorer for checking out contracts on the blockchain. So this for my account, this is my contract address over here. This is my class hash. This is my ETH balance. Basically, you can see I do not have any Ethereum. I don't have any of this account, and this was deployed with on Cairo version 2. I deployed this account on March 8th, 2025. Transactions. So yeah, this is what I'm trying to explain now. So these were transactions I made a long time ago. You can see 6 months or whatever. So now these are the transaction hashes. Then this is the block number. Now you can see on the status, if let me share something. Does anybody in the meet like have like a Bravos or Argent's wallet that can quickly send a few stacks to just to demonstrate something? Yeah, just drop your wallet address in the call. Drop your wallet address in the call messages. Okay, Mr. Basil says he has a Bravos account, so you can just drop it, then I'll send a few. How much though? Just demonstrate something. But before while doing that, you can see the status of this transaction I did, which was a very long time ago. See, it says accepted on L1. So I made this about like 6 months ago. So that was, of course, going to be accepted by this time. So this was the first transaction that happened. So this was a deploy account type of transaction. It happened when I first deployed the account by depositing a few amounts of funds inside. That's my I don't even actively use this account anymore. So this was the type of transaction that happened, and they can see the address and the transaction hash and the whole other details. But when it comes to consecutively, we'll learn more and you'll be more conversant with these terms. And then the next one I do was an invoke function, which was a transfer. I transferred funds to another person to deploy the account. So okay, yeah, I think it has dropped now. Let me think. Okay, it's there. So I don't know, maybe 0.5 star. Give me a second. The network is not as good. Okay. This is taking an awful amount of time. I do not know why. But okay, in the meantime, let's do something then. So this is um his Bravo's yeah, you can see once I searched with his address, his Bravo's account right now, search not found, could not find item because it is not being deployed yet. He just created the account, it's not deployed yet. So unlike mine, that if I copy it right now then put it up, uh you can see the whole everything or whatever. So now right here I'm going to transfer. Hope you guys can see what I'm doing. Anyone paying attention? Reactive your pay. Okay, let's go. So right here I'm going to transfer 0.5. I am stuck to him. See, gas fees are next to negligible, 0.00 stack. So that's very slow. So let's do that. Okay. So the transaction is in progress right now. So yeah, token transfer completed. So I think if I refresh this now, please bear with me, my network is not as good. Yeah, okay, look at this. This is the transaction. This transaction I just did right now. So now see, it is accepted on L2. Instantaneously was accepted on L2, the live transaction now. So now it's accepted on L2, but yet to be accepted on L1. You can see that. So that will take about like a long time. Yeah, look at this. This is the exact this is the transaction I just did right now. Let's see, 59 seconds ago. So you guys are following me, or the transfer. So now, so it was an invoke function. Now it is accepted on L2, but it's not accepted on L1 like the rest. The rest that I did about months ago. So it's accepted on L2 currently, but yet to be accepted on L1. So I hope that made sense. And I think right now his account should be deployed. Sorry. Oh my goodness. Can you? Okay, this is. If we check that now, stack scan, it should be deployed. Okay, something trippy. Okay, no. He has to send funds out. He has to make a transaction with the account now. After depositing funds into the account, he has to make a transaction with the account, like send money out of the account. So I think that's when his account will be deployed. So I think we can go back to slides. So I think I have a few questions for everyone later. So this is how yeah, is anyone having issues setting up the environment, developer environments? Anybody having any issues?
Yes.
Okay, I was planning to host a class tomorrow, like to help anybody that is having issues setting up the developer environments, resolve those. I think
Hello.
tomorrow.
Yeah, please excuse me. I'm just hearing the word developer environment now. I beg. Where was this one discussed? I did not know of anything called developer environment.
It's I think it
Or
was
what is
mentioned
it,
in
please?
it's everything you're going to be using to be writing Cairo code, basically WSL, Scarab and the rest like that. So it's what you're going to be using to be writing Cairo code like that. You get.
Is it like
So I think
remix? Is it like remix to Solidity and all this kind of PyCharm to Python, all kind of stuff?
yeah, somewhat like you have to install Scarab, WSL if you're using, I think you're using Windows, right? And other things you want to have to install on his personal computer. So I think Sakev has the link to the video. It's in GIDA's YouTube channel. It's installing Scarab, and let me find the link and send it to you. That's okay. No, I can't do that. I'll do that at the end of class. I'll drop it at the end of class. Just remind me to do that. Okay, so anybody else that's having any issues setting up the environment, if everybody's okay with it and you're available tomorrow, I can set up a class to help you guys resolve those issues basically. Yeah, cool. So let's talk about the Cairo syntax. So yeah. So this is how Cairo code is structured. Basically, you don't need to understand this now, but it's just for something for you guys to look at something. Basically, so yeah, just have a look at it. For those of you that are familiar with like probably JavaScript or React or Flutter, just take your time to take a look at it. So we have a struct function called rectangle with a height. use64 is like a variable type for basically numbers. And okay, let's look at this. So this is the basic structure. So this defines the contract interface, and then this it modifies the state of the contract, and then this is more or less like a read-only snapshot, I guess. I really do not know how to start explaining most of these terms to everyone right now, because they are more or less complicated, because like U128 bits, U64, like a whole lot of terms that with time, all the time, next week we're going to all get conversant with. So just take your time to look at what each of these align to. If you're familiar with like object-oriented programming and JavaScript and all that, so just take your time and look at where they all align to. But I do have the little ones I can tell you, which I don't think was in this slides though. Those in the slides. So let me go back and type to the call. So I think is a hash contract. These are like ones that I think are very important. So you just check the income messages right now. Okay, these are content. So this is contract. This marks a module as a smart contract. You see it mostly at the beginning of the whole code file and everything. So it marks a module and lets the computer know that you are writing a smart contract. I think check the income messages, you guys should be seeing it. Then next we have hash storage. So now this declares persistent state variables. You can be writing this down. It not be wrong if you be writing this down. You have constructor. So constructors are what they run once. They run once on the contract is being deployed. Next one. No, that's contract again. External. Yeah, we have external. So external, and they're like public functions. Externals are public functions that can modify states relatively. Does all of this make sense? React if you're following, Is everybody following along? Okay, Mr. Uber, just don't worry, everything will be fine. Like, check the income messages. There are a bunch of basically like hash core concept code that I just dropped in there, so I can explain. So the contract it marks that a module is a smart contract. Like, it tells you or lets the computer know that it's a smart contract. And storage declares persistent state variables. Like, let the computer know that wants to be manipulating states, so constantly U64, U128 is going to be utilized, felt 150. Yeah, there's another one I forgot. Felt 252. So I think I can make it public now. Is everyone following along? Okay, yeah, I'm very, very glad to hear that. Let me see. Okay, so you can let me know when you're all okay and conversant with what is on the slides.
How much is this one? When don't buy that one. Don't buy them.
Mr. Ade Jotun. Mr. Ade Jotun, can you turn off your mic? Thank you. So, are we all cool with this? Have you guys read through it? Do you understand? Does everyone understand, or like, are people taking notes of this controls the contract interface, this references and modifies states, this relatively controls snapshots, this is related to metaprogramming, and this can you guess what I'm referring to? Contract states the contract states, the references and modified states, and then this controls snapshots, this controls metaprogramming, this relates to smart contract states, and then this gives access to public methods, and this necessitates interface implementations, like when you're using Next.js to like do front end, but don't worry, you will get into all of that. And this writes storage, this reads from storage, and like you set storage, you set function, you set storage. I think this should make sense. You set an internal storage of size U128, and then you also get storage from that same. Something like you set a box where you're going to be storing things, and then another function to get things from that box again. So that's the whole basic gist. So, and setting up the developer environment, I think, yeah, these are, this is not everything. It's not actually this easy. It was very difficult at me at first when I was having my own bootcamp, but I know everyone will pull through. Just in case you're still having any issues, I'm willing to have a class tomorrow to explain and help you out in your installation. So, Mr. Joseph has a question. You can turn up your mic, sir, and ask a question.
Please, the documents, like the slides, how do we gain access? I don't know that you can send the link to the comment section.
Oh, it's, I have to.
Sorry,
Sorry.
please, can you send it to the group?
Yeah, to be. I'll send it to the group. I will.
Okay, thank you.
I will do. I do not know why it is. For some reason, I can't grant access right now, but I can't change the permissions right now. It's not working. Okay. Strict. Okay, so you should be able to view the link now without any restrictions. Paste it inside. Yeah. Mr. Samuel Adex has a question. You can go ahead, sir.
Yes. And can you please go back to the previous slide? Because I wanted to ask if there's actually Cairo version 1 or version 0, because the code is somehow is too low. It's more like a low-level program language.
Oh, okay. I see. Yeah. You have a
Hello,
point.
can you hear me?
Yeah. It's. I think this one currently is Cairo version 1 that used for this slides is Cairo version 1. So some of the things are not. I know what you mean. Don't worry, everything will be fine. It was just to explain core concepts. Still, do you understand my point?
Yeah, I get it. Thank you.
Okay. So so far, do we have any questions? Or probably terms you didn't understand, so I can explain to you what they meant. If you're taking notes, maybe terms you didn't understand. Okay, Mr. Innocent, you can speak, sir.
So my question is concerning the transaction, like the bundling. I was saying 10 million or 3 million. I didn't really hear that stuff that he said. So I wanted to ask, when the layer 2 is bundling these transactions, like in the block or whatever, when you're talking about when the transactions now are being created and then a new block is created, so they are, let me say, arranged in a new block, like how many transactions are going like is going to make up a block? That's what my question is.
45 million Cairo steps.
Okay, so the Cairo steps is what each transaction is called.
No. I think you're missing. Okay, each block that is being created has the capability to what's it called, contain 45 45 million Cairo steps. But now when you say Cairo steps, they're referring to like individual operations, not the transactions themselves. So like one transaction, I think one transaction is now 10 million Cairo steps. Cairo steps are individual execution that happens in Cairo. Does that make sense? Cool. Mr. Samuel, you can turn on your mic and ask your question, sir. Mr. Samuel, you're raising your hand.
Oh, sorry about that. I've already asked you.
Okay. Mr. Innocent, do you still have a question, sir?
Okay, yeah, you
Mr.
say
Innocent,
yeah, you said tomorrow we are going to have a class on this on setting up the dev environment. And like I want to ask, is it the same time or by what time will it be?
I don't know. It's left to I think I want to put up like a poll on the WhatsApp group whether you guys can agree on a time that would be best convenience for you guys, and I'll fix up my schedule on and whether or not on whatever you guys settle for, basically. So yeah, that's I don't know. Maybe not. It doesn't have to be the same time. Could be earlier if you like. Okay, Mr. Uwa. Mr. Uwa, sir, you're raising your hand.
Okay, I'm talking. I said, is there going to be another moment where we are going to be looking at the Cairo syntax again, or is it the final touch on it?
Yes, 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 you will be. You get to understand more of everything. So I think let's continue. We're almost done. So the exercises I want you guys to do after this class is to install agents and bravos like the browser extensions, and then create an account on Sepolia. Sepolia is like testnet of for Cairo. Testnet like is not on the mainnet, just you understand what the difference between testnet and mainnet is, and then you can request for faucets, and then basically just your regular installations that most of you are yet to do, but that will be sorted out by tomorrow. And so that's basically the end of the class today. I was able to meet up with time. I know it was a little bit challenging. I wasn't clear about some things, but I want to hope that I did my best and everybody understood, even not all, but probably you understood what you could understand. Is that okay? Like, hope you all enjoyed the class, and I tried my very best because it was really, really difficult for me to um conceptualize this knowledge and pass it across and explain it in a simple way to understand. But I know everyone in this boot camp is going to graduate and you're all going to crush it and everything. So we'll all be fine. And yeah. So I will be passing the assignments in the group. I'll let you know information about the assignments. I'll let you know the details on the assignments in the group. I'll put it on the group. And you'll be submitting the assignments before Sunday. Before Sunday midnight. It's for 11:59 Sunday, and to be marked on Monday. To be marked on Monday, and then you get the results and everything. So I hope the whole details about the whole camp was explained and how to graduate and everything. So I think that's the end of the class, and we'll call it a night today. I really hope I did my best, and sorry if I wasn't clear on some things, but yes, God willing, everything's going to be all right, and we are going to learn more about all of this consecutively. So I appreciate all of you guys, and you guys can have a wonderful night. Thank you. Yeah, and lastly, if anyone has, like, if there's any void